Hello everyone, welcome to today's video. The topic of today's video is how to design databases, and in this video we are going to design a database for a blogging website, and we will assume that you have some information about databases, what databases are, what tables are, what relations are. So it's not for absolute beginners, um, it is meant for somebody who wants to perfect his database designing skills. Yeah, so let's get started. I've already prepared a diagram and core components. So our database will be a simple database, simple blogging database. It will cover all the necessary part, but won't be covering like too complicated, because it's just for um, understanding purpose. It's just for understand how to design those kind of databases. Once you have this kind of understanding as according to your scenario, then you can adjust, you can adopt. So let's get started. As you can see here, we have different tables. Let's start with post. Post is the main table. It will store the information of the authors who are writing articles for post. Those information will be stored inside this table, and in this table we will gonna store information like the post title, like introduction, body, summary. These three informations we are gonna store. That's the main information that we are gonna require for the post table. And now let's look at the other table. Here we have comments. So every post has comments, so user comments on the articles or the post of the user, so that information will go here in comments table. Then we have users table, the authors table, author who is writing the table post. That user information will be stored inside this users table. And then that we have tags table. This is the additional information associated with your post. You normally see sometimes in your left or right those tags. This is the information. And tags would be like independent of the post. It can be used with other posts and something like that. So that's the idea. Tags will be stored separately in a table. Then we have a category, pre-listed category defined by the admin or the who is running the website. They will define the categories, and the post is associated. Post will have this category associated with it. And then lastly we have a metadata. Metadata is more about SEO, and it's for search engines, so that information will be stored inside this metadata table. So I have already prepared a SQL script. Now let's switch to SQL script and see what do we need to do, how to create these tables. Let's create these tables in the real time. Okay, first of all, let's create a database. As you can see, I don't have any databases here, so let's create a database. Okay, it's showing me again the connection window. Yeah, okay, I think it has already created. Yes, you can see the database, but it's not selected, so you can either select it here, or can use this command. It will select here. So as I said, the post is the main table. You can see here we have the simple table. Let's see what do we have here. ID, primary key, not null label, auto increment. This identity specifies that it's the auto increment by 1. Then we have a category ID. Category is this thing. And so we have a pre-listed categories, and we associate that category ID with it, with our table. It's a foreign key relation. It's really important that we should create those relations like a foreign key relations. And I think it cannot be null default. That's wrong here. And Yes, it's a foreign key relation. It's important you create those keys, foreign keys, because if you don't create those foreign keys, then your data integrity will be affected. So this means that if any ID does not, if you can only create or you can only write, enter a post inside this table if a ID already exists in this table. That's how you make sure the ID already exists. So you cannot create post for the wrong categories. So it will make sure that ID exists. That's why it's important to have those foreign keys, those relations. So always create foreign keys for those kind of relations. Then we have, as I mentioned, title, introduction, body, and summary. These are the main information that author is going to enter, and we are going to store it as a nvarchar. Nvarchar is for Unicode, and if we talk about nvarchar max, it's like it can store up to 2 gigabytes, which is a huge amount of data we can store. And then we have author ID, the users who is authoring it. It's also a foreign key associated. It's a one to many relations. These two are one to many relations. This means an author can write many posts, but a post cannot have many authors. Can have only one author. Post can have only one author. That's why we have ID here, not here. Post ID here. That's how it works. And same goes for categories. Inside categories we have category IDs here. So this means a post can have only one category, but a category can be assigned to multiple posts. That's why the category ID and author ID is here. Inside category tables, you see this strange kind of key relation. It's called self-referencing. Why do we need self-referencing? It's here we are referencing itself. It's a parent ID because we want to achieve kind of a hierarchical structure. That's why we have this self-referencing concept here. And it's like for example, you consider a scenario, you have a category information technology, and it comes in IoT, machine learning, big data, software engineering, and whatsoever. So that's why in that case the information technology will be the parent key of those subcategories, and the parent key will have a null value. That's the idea here, to self-reference. And it will also by creating those foreign keys, it will also make sure that you have associated a correct, not correct in a way, that a parent key must exist in your table. So if that's the benefit of using foreign keys here. It's also data integrity. So always always use foreign keys if you are doing such kind of relations. It will increase your data integrity. Okay, yeah, that's it about, I think, category and post. And here I think we don't have any further information. Yeah, I mean, it's published, it's byte is published, it's 1 or 0. It's like a boolean here. It will tell you, okay, if the post is published or not. Then the date time, published date time, it can be null. If it's not published, then the date time will be null, of course. And the creation date time and last edit, it's like a more like a tracking or kind of field that tell you when the post is created and when's the last modified. It's, for me, it's more like a standard thing. I do it with almost all the tables in order to keep track the changes. Yeah. So I'll create, if I cannot, if I create the post table, I'll get error straightforward because it has two dependencies. Because before creating post, we need to create those two tables, and then we will be able to create post. Okay, now we have in our database, we should have three tables available. Okay, next we have a comment table. Comments table. Here we are gonna store the users comments. I think comments table is the main component is content, where we are gonna store the content of the comment, and then the user ID, the user who is commenting on it, who has commented, and the post the um, on which the comment is made. And it's also important to see the relations. It's a one to many relations, so this means a comment can have only one users, and comment can be associated to one post only. If you notice the difference, what was the difference with users and categories relation? In the users and category relations is um, a post can have only one user and one category. That's why category ID and the author ID is here. But if you see, in that case the comment ID is not here, but the post ID is in the comments table. So it tells you that a post can have many comments, but a comment cannot have many posts associated with it. That's why it's one to many. And as with categories, it's also contains self-referencing. With parent ID, it's for achieving those hierarchical structure. With consider those scenarios when somebody responds on your thread, and you want to have that kind of hierarchy preserved. That's why you have this parent ID of those comments, and you will store for those sub comments. Therefore we need it. Okay, yes, that's I think it for comment table. I'll create comments, and then we have tag table. Here we are gonna store the tags. Pretty straightforward. Tag name is important. I think watch max it's too much for it. We can have something like that. I think tag length should be 500 max, should not be more than that. And there we have a one to many relations. Previously we had only one to one relations, but with tags it's like one many to many relations. So this means that a post can have many tags associated with it, and a tag can have many posts. So it's many to many relations. It's important because it's increase the reusability also. You can have existing tags you can reuse with different posts, and posts can have many tags. That's why we need this mapping table. Mapping table is straightforward. We have first name table underscore last the second table name. That's how I create mapping tables, and it contains only 3 fields: ID, the primary key of that table, and then the tag ID, foreign key, this ID, and the post ID. That's how you store those mapping information. And lastly we have this metadata table. Metadata table is those store SEO information. Here we have important part is metadata key and metadata content. This is this HTML metadata. This information we store here, and of course the post ID, which for which this metadata is associated. It's like the relation is similar to comments. Like a post can have many metadata, but a metadata cannot be associated to many posts. That's why it's one to many relation. So I'll create it. Now I think we have almost all the tables here in our database what we need, and I think the database structure is complete for this our simple blogging website. And in the next video we will see how we will interact with it, how we will insert the data, and how we can retrieve the data from the SQL queries, of course. Thanks for watching. Bye bye.